Hi, and welcome back to another video. So next, let's take a look at Ethereum and its structure. So Ethereum is a decentralized open source blockchain with smart contract functionality. The native cryptocurrency of the platform is Ether, and the Ethereum network went live in 2015. As a blockchain network, Ethereum is a decentralized public ledger for verifying and recording transactions. The network's users can create, publish, monetize, and use applications on the platform, and use its Ether cryptocurrency as payment. The decentralized applications on the network are called dApps. Ethereum was created to enable developers to build and publish smart contracts and dApps that can be used without the risks of downtime, fraud, or interference from a third party. Ethereum describes itself as the world's programmable blockchain. It distinguishes itself from Bitcoin as a programmable network that serves as a marketplace for financial services, games, and apps, where all of which can be paid for in Ether and are safe from fraud, theft, or censorship. The Ether cryptocurrency was designed to be used within the network. However, like Bitcoin, Ether is now an accepted form of payment by some merchants and service vendors. So, for example, Shopify and Cheap Air. And its invulnerability to hackers and other snoopers has opened possibilities for the storage of private information, from healthcare records to voting systems. Currently, Ethereum can handle around 30 transactions per second, and it uses the ETH algorithm for its proof of work. And it takes around 14 to 15 seconds to mine a block, and generally 5 ethers are issued per block. So just like Bitcoin, Ether is a metric unit and can be divided into its smaller subunit known as Wei. So digital cryptocurrencies are divisible into much smaller units like this. So Ethereum currently uses the proof of work consensus mechanism, where I mentioned about how it works in the previous Bitcoin video. And actually, Ethereum has plans to upgrade to the proof of stake consensus mechanism in the future. So it requires users to stake their Ether to become a validator in the network. Validators are responsible for the same thing as miners in the proof of work consensus mechanism, where they order transactions and create new blocks so that all nodes can agree on the state of the network. The proof of stake comes with several improvements to the proof of work system. Firstly, better energy efficiency. You don't have to use lots of energy to mine these blocks. And secondly, lower barriers to entry, reduced hardware requirements, where you don't need any elite hardware to stand a chance at creating new blocks. Thirdly, stronger immunity to centralization, where a proof of stake should lead to more nodes in the network. And lastly, stronger support for shard chains, which is a key upgrade in scaling the Ethereum network. So proof of stake is the underlying mechanism that activates validators upon receipt of enough stake. For Ethereum, users will need to stake 32 Ether to become a validator. Validators are chosen at random to create blocks and are responsible for checking and confirming blocks they don't create. A user's stake is also used as an incentive for good validator behavior. So, for example, a user can lose a portion of their stake for things like going offline, which means they have failed to validate, or they could lose their entire stake for deliberate collusion. So, unlike proof of work, validators don't need to use a significant amount of computational power because they're selected at random and they aren't competing with each other. So they don't need to mine blocks, they just have to create blocks when they are chosen and then validate proposed blocks when they're not. So this is known as attesting. So validators get rewards for proposing new blocks and for attesting to ones they've seen. And if you attest to malicious blocks, you lose your stake. So here we have the beacon chain. So when Ethereum replaces proof of work with proof of stake, there will be added complexity of shard chains. So these are separate blockchains that will need validators to process transactions and create new blocks. So the plan here is to have 64 shard chains, which each having a shared understanding of the state of the network. As a result, extra coordination is necessary and will be done by the beacon chain. The beacon chain receives state information from shards and makes it available for other shards, allowing the network to stay in sync. The beacon chain will also manage the validators from registering their stake deposits to issuing their rewards and penalties. I'll be expanding on what sharding is. So here is how the validation process works. When you submit a transaction on a shard, a validator will be responsible for adding your transaction to a shard block. Validators are algorithmically chosen by the beacon chain to propose new blocks. And then firstly, we have the attestation. So if a validator is not chosen to propose a new shard block, they'll have to attest to another validator's proposal and confirm that everything looks okay. So it's the attestation that's recorded in the beacon chain rather than the transaction itself. And then at least 128 validators are required to attest to each shard block. And this is known as a committee. So the committee will have a time frame in which to propose and then validate a shard block, and this is known as a slot. So only one valid block is created per slot, and there are 32 slots in an epoch. So after each epoch, the committee is disbanded and then reformed with different and random participants. So this is something that helps to keep the shards safe from committees of bad actors. And then next we have cross links. So once a new shard block proposal has enough attestations, a crosslink is created which confirms the inclusion of the block and your transaction in the beacon chain. So once there's a crosslink, the validator who proposed the block gets their reward. And then lastly, finality. So in distributed networks, a transaction has finality when it's part of the block that can't be changed. So to do this in proof of stake, Casper, a finality protocol, so it gets validators to agree on the state of the block at certain checkpoints. So long as 2/3 of the validators agree, the block is finalized. So validators will lose their entire stake if they try and revert to this later on via a 51% attack. So when it comes to security, the threat of a 51% attack still exists in proof of stake, but it's even more risky for the attackers. So to do so, you need to control 51% of the staked Ether. So not only is this a lot of money, but it also probably causes Ether's value to drop. So there's actually very little incentive to destroy the value of a currency you have a majority stake in, right? So there are stronger incentives to keep the network secure and healthy. So what are some pros and cons of proof of stake? So for the pros, firstly, staking makes it easier for you to run a node. It doesn't require huge investments in hardware or energy. And if you don't have enough Ether to stake, you can also join staking pools. And then secondly, staking is more decentralized. So it allows for increased participation, and more nodes doesn't mean increased percentage of returns like with mining. And then lastly, staking allows for secure sharding. So shard chains allow Ethereum to create multiple blocks at the same time, increasing transaction throughput. Sharding the network in a proof-of-work system would simply lower the power needed to compromise a portion of the network. And then for the cons, so basically proof of stake is still in its infancy stage and it's less battle tested as compared to proof of work. So now let's take a look at the block structure of Ethereum. So Ethereum block stores several important data such as the previous block hash, the timestamp, the difficulty, and so on. So from this image over here, you can see the components of a block. So you can see the hash root. As you can see, the block has 3 types of hash root. There's the transaction hash root, the receipt hash root, and also the world state hash root. And then we also have the nonce. So in cryptography, a nonce is a one-time code chosen randomly to transmit passwords securely and prevent replay attacks. So Ethereum has two types of nonce. There's the proof of work nonce and then the account nonce. So nonce in the block is proof of work nonce that is used as a meaningless number when mining. So on the other hand, the nonce in a transaction is an account nonce that represents an order of transaction that an account creates. And then we also have the block gas limit. So it shows the gas limit and the gas use, which I will touch on in just a bit. And lastly, we have the uncle block. So the uncle block in Ethereum is equivalent to the orphan block in Bitcoin. The uncle block is a block which is mined correctly but not accepted because of the network time lag. In mining, it occasionally happens when two different miners generate the same block simultaneously and only one of them is adopted in the blockchain. So unlike orphan blocks in Bitcoin, Ethereum rewards for uncle blocks to neutralize the effect of network lag and decrease centralization by large miners. And next we have smart contracts. So Ethereum was created to enable developers to build and publish smart contracts and dApps that can be used without the risks of downtime, fraud, or interference from a third party, which I mentioned just now. So before I dive into smart contracts, let's understand what a contract means. So a contract is simply an agreement between two private parties that creates a mutual legal obligation. So a contract can be either oral or written. So what is a smart contract then? So smart contracts are simply programs stored on a blockchain that run when predetermined conditions are met. They typically are used to automate the execution of an agreement so that all participants can immediately be certain of the outcome without any intermediaries' involvement or time loss. And they can also automate a workflow, triggering the next action when conditions are met. And these smart contracts are often written in a programming language called Solidity, a language that's kind of like JavaScript and C++. And other languages for writing smart contracts include Viper and Bamboo. So how do they work? So smart contracts work by following a simple if or when, and then, So these statements are written into a code on the blockchain. Okay, so for example, like if you pay the rent this month, then the landlord will let you stay at his place. So a concept like this. So a network of computers executes the action when predetermined conditions have been met and verified. So these actions could include releasing funds to the appropriate parties, registering a vehicle, sending notifications, or issuing a ticket. So the blockchain will be then updated when the transaction is complete. So this means that the transaction cannot be changed and only parties who have been granted permission can see the results. And within a smart contract, there can be as many stipulations as needed to satisfy the participants that the task will be completed satisfactorily. So to establish the terms, participants must determine how transactions and their data are represented on a blockchain and agree on the if or when something happens, then something will happen rule that govern these transactions, and then they explore all possible exceptions and then define a framework for resolving disputes like this. So, and then the smart contract can be programmed by a developer. So let's look at some benefits and applications of smart contracts. So for the benefits, firstly, we have speed, efficiency, and accuracy. So once a condition is met, the contract is executed immediately. And because smart contracts are digital and automated, there's no paperwork to process and no time spent reconciling errors that often result from manually filing in documents. Secondly, trust and transparency. So because there's no third party involved, and because encrypted records of transactions are shared across participants, there's no need to question whether information has been altered for personal benefit. And thirdly, we have security. So blockchain transactions records are encrypted, which make them very hard to hack. And moreover, because each record is connected to the previous and subsequent records on a distributed ledger, hackers would have to alter the entire chain to change a single record. And then next we have the applications. So firstly, for insurance, like automatically triggering claims on your behalf if it has been detected that you've been affected. So maybe for example, your property being affected by natural disasters. And secondly, employment contracts. So you can handle contracts of temporary or part-time staff and people who are like prone to employer or agency abuse. And then lastly, voting. So auto validation of voter identity, anonymity, and also quicken the accounting process. So next we have the Ethereum virtual machine. So the EVM is a component of the Ethereum network that manages the deployment and execution of smart contracts. While the EVM doesn't need to be engaged for simple value transfers, it does compute updates to the network state. So in layman's term, the EVM is a world computer with its own permanent data storage and decentralized nodes across the globe, handling millions of executable objects. So it also has a stack-based architecture, storing all in-memory values on a stack. And next we have gas. So let's revisit this, which I mentioned under block structure just now. So gas is a unit that measures the amount of computational effort that it will take to execute certain operations. So you must pay a gas fee in order to make a transaction or execute a smart contract on Ethereum. And regardless of the wallet you use, you will always need to pay for gas when executing transactions. So most of the smart contracts that run in the EVM are coded using Solidity. So every line of code in Solidity requires a certain amount of gas to be executed, where the minimum for every transaction is 21,000 gas. So why do gas fees exist, right? So like any proof of work peer-to-peer system, Ethereum is heavily dependent on the hash rate of their miners. So the more the miners, the more the hash rate, and the more secure and fast the system will be. So by having this fee, it helps incentivize miners to take part actively in the ecosystem to use their computational power to validate smart contracts. So in short, gas fees help to keep the Ethereum network secure. By requiring a fee for every computation executed on the network, we prevent actors from spamming the network. In order to prevent accidental or hostile infinite loops or other computational wastage in code, each transaction is required to set a limit to how many computational steps of code execution it can use. So, although a transaction includes a limit, any gas unused in the transaction will be returned to the user. And next, why can gas fees get so high? So high gas fees are due to the popularity of Ethereum. Performing any operation on Ethereum requires consuming gas, and gas space is limited per block. So this includes calculation, storing, or manipulating data, or transferring tokens, where each consumes a different amount of gas units. As depth functionality grows more complex, the number of operations a smart contract performs grows too, meaning each transaction takes up more space of a limited size block. And if there's too much demand, users must offer a higher gas price to try and outbid other users' transactions. So a higher price can make it more likely that your transaction will get onto the next block. And gas price alone does not actually determine how much we pay for a particular transaction. To calculate the transaction fee, we have to multiply the gas used by gas price, which is usually measured in Gwei. And next, for the gas limit, so gas fees are denoted in Gwei, so which is just 0.000000001 Ether. So for every transaction you want to make, you have to set what fee you're willing to pay for a transaction to be executed. So the maximum amount of gas you're willing to pay for a particular transaction is called the gas limit. So additionally, you must input the gas price for each transaction as well. So the gas limit times the gas price equals the gas fee, and you pay the gas fee when you submit a transaction. And then this gas is used to just allocate resources in the EVM. So for example, okay, let's say Gary has to pay me 1 Ether. So in a transaction, the gas limit is 21,000 units, and then the gas price is 200 Gwei. So the total fee will be 21,000 times 200, which is 4.2 million Gwei, which is also equivalent to 0.0042 Ether. So now when Gary sends the money, 1.0042 Ether will be deducted from his account, and then I'll get the 1 Ether, and then the miner will get 0.0042 Ether. So when you submit a transaction on Ethereum, you're actually competing with other people who also want to submit a transaction. So each person is trying to have their transaction executed at the same time. But only so many transactions can be included in an Ethereum block, right? And then there are only new blocks every roughly 13 seconds. So in fact, each block contains only around 12.5 million units of gas. So this means everyone is competing against one another to have their transaction included in the next block. So when the demand is high and the supply is constrained, since only this many transactions can be included in a block, gas prices must increase. So these transactions go into the mempool, which is short for memory pool. The mempool is where all the transactions that have been submitted but not yet verified live in. So in short, the mempool is kind of like a waiting queue for validation. So miners who validate transactions before execution to make sure they are not malicious, and then they pick the transactions that should be included in the next block from the mempool. And miners select what transactions should be included in the next block based on how high the gas fee users set prior to submitting the transaction. So the higher the gas fee, the higher chance a miner will be willing to include your transaction in the next block. And this situation is where the competition comes in, since you compete with everyone else setting gas fees during that time frame for block space. And next we have sharding, which I mentioned under proof of stake. So sharding refers to the splitting of the entire Ethereum network into multiple portions called shards. So each shard would contain its own independent state, meaning a unique set of account balances and smart contracts. So sharding is the most complex Ethereum scaling solution, and I'll explain more on scaling in a later video. So in the Ethereum network, nodes are responsible for verifying the miner's work and ensuring that consensus rules are followed. So the best way to do this is to keep a full copy of the Ethereum ledger. And that way it's very easy to verify a miner's work. But the Ethereum blockchain is approaching 1 terabyte of storage, so it's quite impractical for a regular person to run the node. So if the Ethereum nodes become too expensive to run, the network will become more susceptible to centralization, and at the same time, requiring each transaction to be processed by every node will make it so Ethereum never scales. So sharding is the potential solution to this very problem. So what it's doing is attempting to break up the blockchain into multiple parts, so nodes aren't responsible for processing every transaction broadcasted onto the network. So sharding is Ethereum's most formidable option to solve the scalability trilemma, where no blockchain can be decentralized, scalable, and secure at the same time. So just imagine if Ethereum was split into thousands of islands, and then each island can do its own thing, it can have its own features, and everyone belonging to that island can just enjoy it. So if they want to contact other islands, they have to use some sort of protocol. So this is what sharding does. It creates a way for each shard to store individual receipts of each transaction, and since they're cryptographically secure, they can be brought back to the main chain at any point in time. So while sharding sounds really great in theory, there are several potential attack vectors. So one specific attack is the single shard takeover attack. And in this scheme, an attacker takes over the majority of block producers in a shard to create malicious shard that can submit invalid transactions. So the Ethereum core developers point to random sampling as a solution, and this is still in active development. And then Sharding is also much easier to implement on a proof of stake chain than it is on a proof of work chain. So there are already active validators within proof of stake, which can be randomly assigned to different shards. And in proof of work, nothing can be done to completely stop a miner from contributing hash power to a particular shard. And if they know the shard they are validating, they could potentially try and orchestrate some collusion. And next, Serenity. Okay, so you might have seen some articles regarding Ethereum 2.0, and it's been receiving quite a lot of attention lately. So Ethereum is planning a major update to its network, which is the Ethereum 2.0 upgrade. So it aims to address the network's scalability and security. In the first phase of the upgrade, Ethereum will change its consensus mechanism from proof of work to proof of stake. And the upgrade aims to enhance the speed, efficiency, and scalability of the Ethereum network so that it can process more transactions and also ease bottlenecks. So one of the main reasons for the upgrade is scalability. And with Ethereum 1.0, the network can only support around 30 transactions per second. So this causes like a lot of delays and congestions. And then Ethereum 2.0 promises up to 100,000 transactions per second. And this increase will be achieved through the implementation of shard chains. And also, Ethereum 2.0 has been devised with security in mind. So most proof-of-stake networks have a small set of validators, which makes for a more centralized system and decreased network security. And for Ethereum 2.0, it requires a minimum of 16,384 validators, making it much more decentralized and hence secure. So how will this upgrade slowly take place? So the phase 0 sees the implementation of the beacon chain. So this stores and manages the registry of validators, as well as deploying the proof of stake consensus mechanism. So the original Ethereum proof of work chain will run alongside this so that there's no break in data continuity. And then proof of stake is introduced as it's easier than mining, and it helps make Ethereum more secure in the long run. And by having more people participate in the network, the more decentralized and safer from attack it will be. And then next, in phase 1, the merge, which is due this year, we'll see the integration of proof of stake shard chains. So the network is expected to launch with 64 shards, which means enabling 64 times more throughput than Ethereum 1.0. But then at launch, they won't support accounts or smart contracts yet. And then we have a phase 1.5. So it's an interim update also due this year. And we'll see the Ethereum mainnet officially becoming a shard and transitioning to proof of stake. So this merge will signal the end of proof of work for Ethereum and start the era of a more sustainable and eco-friendly Ethereum. And then finally in phase 2, shard chains is slotted to launch either this year or the next, and it will see shards becoming fully functional and compatible with smart contracts. And then it also involves adding Ether accounts and enabling transfers and withdrawals, implementing cross-shard transfers and contract calls. So it will build execution environments for scalable apps that are built on top of Ethereum 2.0. So this update is a hard fork and it is known as London. So some impacts of this upgrade, definitely firstly will be gas fees. So it's the biggest change in Ethereum 2.0 is how they are adopting a new method of rewarding miners. So far, the Ethereum platform has rewarded miners for validating transactions, and that happens every few seconds, while also awarding the transaction fees, which is the gas fees, for each transaction to these miners. So this is the biggest source of revenue for miners, and then because they're just rewarded for doing their work, right? So after this London fork, the transaction fees will actually no longer be awarded to the miners, which means that they'll lose like a big source of their revenue. And then in this new proof of stake model, it actually requires miners to put up a stake in the form of their own Ether. So only a select number putting up the largest stakes will be rewarded for validating transactions. So this means most miners, especially those with smaller holdings, will lose a massive amount of revenue. And then those who are still getting rewards will also get less. And then another impact will be computing power. So basically, reduce computing power involved in Ethereum mining. Okay, so through this video, you should have had a better understanding of Ethereum and its structure. So Ethereum is an open source software framework which is based on a blockchain technology. Ethereum helps you build smart contracts and decentralized applications without any downtime or third-party interference. And Ethereum was launched in 2013 by developer Vitalik Buterin. And smart contracts allow blockchain users to exchange money and property. And mining Ethereum can be used for smart contracts as well as digital currency. So Ether is a value token of the Ethereum blockchain, and it's listed as ETH on crypto exchanges. So to perform a transaction on the Ethereum network, a user will have to make a payment to the miner in Ether via an intermediary token called gas. And lastly, for Ethereum 2.0, it makes Ethereum more scalable, secure, and sustainable. So this will be accomplished by changing its consensus mechanism from proof of work to proof of stake, and where this proof of stake model allows Ethereum holders to stake their holdings to stake pools that will earn rewards and grow their holdings over time. So the current cost for transactions on Ethereum's network is very high and prevents many from using it. So if this update is really successful, the reduced fees it will bring will make the network more practical for the average user. And Ethereum's upgrade could have a profound effect on its price, as its lower fees and faster transactions open a network to a broader demographic of users. Okay, thanks for tuning in, and I'll see you in the next video. Bye!